So the ocean is getting more acidic. We're adding carbonic acid. What exactly does that do to that ecosystem? So here's the equation that I've already given you before. When you have carbon dioxide and water, you're going to make a molecule of carbonic acid. Make sure you know that H2CO3 is carbonic acid. Now I'm going to introduce two more molecules to you. So now we have more carbonic acid in our ocean. So we've got more of this because we have more CO2. There are minerals in the oceans and in our water called carbonate or carbonate. That carbonate, that equation is CO3. And think of a mineral just like having calcium in the water or potassium in the water. This is just a mineral that's naturally found there and really, really important to the ecosystem. Now, carbonic acid binds to carbonate really, really easily, like really easily. It almost seeks out carbonate to bond with it. And when it bonds with it, what it does is it donates one of these H's. H's stand for hydrogen. So here we have hydrogen. And the C is for carbon. So this carbonic acid, which has been made because we increase carbon dioxide, is really looking for carbonate that is in the water, that's naturally in the water. And when it does that, it's going to change this carbonate to a different form. It's going to make HCO3, and it makes two of these molecules, which should make sense. Here we've got two H's, CO3 and CO3. Well, here we have two H's and two CO3, CO3. This new molecule that is made is bicarbonate. So I know these are new formulas and new words and minerals that you don't know. So I recommend making flashcards of these just to learn the formulas of these. Because these formulas are very, very important to understand ocean acidification. So again, carbonic acid made from carbon dioxide. It binds with carbonate that is found in the water. When it binds with that carbonate, it's going to make bicarbonate. The main point here is this carbonate. So we lose carbonate in the water. And this is what's really, really important. And this is what ties into the ecosystem. The point being, carbonate's no longer around, or not as much of it is around, because carbonic acid keeps binding with it. You might think, oh, well, bicarbonate's not that different. It is different enough that our body cannot use it. So why does this matter? I'm going to give you one more molecule, and I promise it'll be done. So I said that carbonate, that CO3, is incredibly important to the ecosystem. But why? Well, it's not important to all organisms, but it is important to organisms that make shells. Specifically, organisms that make shells out of calcium carbonate. If you look at the molecular formula, we have calcium and we have carbonate. What these organisms do, like snails, urchins, corals, what they do is they take carbonate out of the water, they take calcium out of the water, they put it together to make a shell. And without those shells, those organisms couldn't exist at all. So those are the ones who are being affected. They need that carbonate, but it's not around anymore. So I'm showing you same exact equations. Nothing is new here. This acidic water is doing two things. The first thing it does is it takes carbonate out of the water. Here's that equation we looked at. We have our carbonic acid plus carbonate. Again, this is just in the water. And that binds to make bicarbonate. That means there's less carbonate around. That means that shelled organisms like a snail that needs carbonate, there's not that much left of it anymore. It's all been churned into something else. And so that snail has a hard time making its shell. So it doesn't get as big, or maybe it doesn't survive. Or that coral doesn't get to make its skeleton, and so it dies quicker. These organisms, although maybe we don't eat coral or that kind of snail or that urchin, these organisms have incredibly important parts in the food chain. There's tons of shelled organisms that are microscopic, that are at the bottom of the food chain. If you get rid of those, you're altering the entire ecosystem. So again, the first thing that happens is acidic water makes carbonic acid. Or sorry, carbon dioxide makes carbonic acid. Then that carbonic acid is going to bind with any carbonate that's found in the water and gets rid of that carbonate. It turns that carbonate into something else. Well, shelled organisms are screwed. They needed that carbonate. Now, we don't have so much carbonic acid that all the carbonate's going away, but there is less than there used to be. The second problem with increased carbon dioxide is this equation, and this equation is very, very similar to the last equation. Here we have carbonic acid, and before I said it takes out carbonate. It's really good at taking out carbonate, so good that it can actually take and steal away carbonate from calcium carbonate. Remember, calcium carbonate is found in our shelled organisms. So here's this new acid water. This is from carbon dioxide. It goes in the water. It's going to take carbonate that's in the water. It's going to bind with it. But it's so good, it's actually going to start dissolving shells because it wants to bind with that carbonate that is found in that calcium carbonate shell. And it makes the same thing. It still makes this bicarbonate, and then this calcium is just floating back in the water column. So not only does carbonic acid take away carbonate that's in the water, it also takes away carbonate that are in shells that were already made. So what happens is those organisms start breaking down. You've actually seen this before. We'll talk about acid rain in our following lecture, but acid rain affects limestone statues. Limestone, which you may have used in a garden or in your yard, limestone is calcium carbonate. Another thing that is calcium carbonate is chalk. Acid rain has carbonic acid as well as other acids in it, and it breaks down these limestone statues. You can actually do an experiment at home. If you happen to have chalk, if you put Sprite or some other clear soda in a cup with chalk in it, that chalk starts breaking down. That Sprite has carbon dioxide in it. That's what all those little bubbles are. It has carbonic acid in it, and you'll actually start seeing breaking down calcium carbonate. So although know that chalk isn't making a shell, its shell is breaking down. So you actually already know these concepts, but just practicing with these different equations. So that is it for the chemistry. Definitely practice those. Rewrite those equations. Not only memorize, oh, it's CO2 plus H2O equals H2CO3. What are those things? What is carbon dioxide? Where is it coming from? What is carbonic acid? What does it do? So make sure not only that you're memorizing the equations, but also understanding what is each thing in that equation. What is it doing to each thing in that equation?